Suppose now that we have a demand versus price linear function. Okay, the more you charge, the fewer are going to be bought. So you should pause at this point and make a table of demand versus price. For example, when the price is 0, the demand is 200. When the price is 40, the demand is 0. Fill in the table using estimates based on what you see on the graph and see what numbers you get. Now, assuming you've paused, I'm just going to do this. I didn't tell you in what increment. That's up to you. I'm going to use increment 10, 10, 20, 30, 40. This is a linear function. It goes down from 200 to 150 to 100 to 50, then to 0. So since this line has constant slope, the ideal results will be that when the price is 10, the demand is 150. When the price is 20, the demand is 100. When the price is 30, the demand is 50. Now, if you did actual estimates, since I didn't line these off with complete uniformity, your estimates could have varied. For example, if I go directly above 10 and project this over, I get a number just a little more than 150 if I used the actual graph that I drew. So your numbers might deviate from these slightly, but they're going to be in this general ballpark. Of course, he didn't necessarily use 10, 20, and 30, but we see the progression. Now, what I want to do is figure out the revenue. Now, the revenue is how much money we get. So if we sell 10 items, 150 items at $10 a piece, how much money do we get? See if you can fill out the revenue column before I do it. Now, you should have paused and done that, but I'm going to do it for you. If we sell 0 items at $200, we're not going to make any money at all. If we sell 10 items at 150, well, we're going to make we're not going to make $1,500, but we're going to take in $1,500. This is revenue. This is not profit. Profit is what we would say we make. To get the profit, you have to subtract what it cost you to produce these items or to obtain them. Okay, well, we'll get to that. But okay, price 20, and you sell 100. That gives you $2,000 in revenue. 30 at 50 is 1,500. 40 at 0, of course, you're not selling any, so you're not taking in any money. So those are the numbers we get. So if we plot the revenue function, the first thing you would see in the revenue function is there's a symmetry to these numbers. Pause, see if you can identify the symmetry. I would recommend you jot down your description of the symmetry. Okay, well, hopefully you've done so. Now, if we plot revenue versus price, we get prices 10, 20, 30, 40. We got a revenue of 0 for a price of 0. For a price of 10, we're going to sell 150. We're going to have $1,500 in revenue. Revenue goes up to $2,000, so let's just mark 2,000 up here. Let's cut that in half, make that 1,000, and then we'll put marks for 500 and 150. So the 10, 1,500 is going to go here and across from the 1,500. I think I said 150 when I marked that 1,500. 500 here, 1,500 here. Not sure what I said. Okay. For price of 20, of course that's 10, 20, 30, 40. For price of 20, we have revenue of 2,000. For 30, we have a revenue of 1,500. So that will also be directly across here. And for 40, we have a revenue of 0. So there's 4 points, 5 points on our revenue versus price function. We could plot a curve through these points. It looks like a parabola. Is it? As a matter of fact, I go a little further. It looks like a parabola with an axis of symmetry. At P equals 20. And if so, the vertex at 22,000. And that would indicate that the maximum revenue occurs when we set the price at $20. Okay, so the question is this really a parabola? Well, the demand function here is a linear function. It's got a y-intercept or a vertical intercept of 200, and it's got a slope. Well, it goes down 200 for a run. The rise is negative 200 when the run is 40, which gives us a slope of negative 5. So the demand function is negative 5p plus 200. Okay, now it's using what we know about linear functions, we can easily enough find the demand function, assuming it's a linear function. Okay, so what's the revenue? Well, how did we get the revenue? We multiplied the price by the demand. So see if you can write down the function in terms of P that gives us the revenue. In other words, if we sell P items, there's a P here on this axis, we can figure out the demand using this function. And then what do we do with that to get the revenue? You should pause and see if you can do that. Well, hopefully you pause. The revenue is just price times the number sold, and the number sold is just another word for the demand, or the demand is actually the word we use for the number sold. So that's price times demand. Okay, we're multiplying price times demand, or price times X if we're going to let X stand for the demand. Now I use X here. X is not the horizontal axis. The horizontal axis is price. We could use X to stand for the quantity in the vertical axis, and that seems a little weird, but we can do that. So, you know, get used to it, because your textbook does it, and most textbooks do it, and that's standard notation in economics. Okay, as if I know enough economics to tell you what's really standard there. Trust me in physics, don't trust me in economics. Revenue is price times demand, which is, using big R for revenue, it's price times the demand, which is negative 5p squared plus 200p. Okay, and that is a quadratic function. So that's a quadratic function with a parabolic graph. Now, using what you know about parabolas, you should pause and see if you can tell me where the vertex, where's the axis of symmetry for this function, where are the zeros, and where's the vertex. I'm actually going to calculate that in the next video, so you're going to have a little time to work that out. You should be able to work that out. Now you see what the answers should be from this graph, but can you work it out using the techniques of quadratic functions.